This is a production of Cornell University.
Hey, everybody. I'm excited to be here today. Thank you for the kind introductions. A bunch of you nodded when you heard about Chris Walsh. So fun fact, I started with Chris as his grad student. I was going to take a year off between undergrad and my master's just to work on the farm. I just wanted to go back to the farm, work full time. And then Chris actually sat next to my mom at one of those winter vegetable growers meetings. He's like, "Are you Donna's mom?" And she's like, "Yeah." And he said, "I want her to be my grad student." So I got a text, "Talk to Dr. Walsh. He wants you as a grad student." And here I am, like 15 years later. Okay, so so I'm here today to sort of talk about a couple of different things, primarily produce safety using soil amendments as an example. As Betsy said, growing up on a produce farm, I guess I would say I'm a food scientist. I work in the Department of Food Sciences, but at heart, I love agriculture and I love working with farmers. So that's sort of where soil amendments comes in. Um, I'm going to give a very quick introduction to produce safety to sort of set the context, set the stage for talking about the use of soil amendments in building an extension program. I'm going to mention how different soil amendments are used on produce farms, especially organic produce farms, practices to reduce microbial risk through soil amendment use, and then talking a little bit more about the importance of extension in supporting farmers. So to set the stage a little bit, I wanted to talk about our program, the Produce Safety Alliance. I have the privilege of working with, I want to say 12 or so folks on the team. And together we are the Produce Safety Alliance. Our primary goal is to provide produce safety training to growers. We are most known for the grower training course. I don't know how many in the room here have taken the course or are aware of it. Cumulatively, along with all of our PSA trainers, nationally and internationally, we've taught over 101,000 participants at this course, a lot of growers, regulators. The idea is to teach to the FSMA Produce Safety Rule regulation, both teaching growers, helping growers empower and understand, implement these risk reduction practices. A lot of times we call these good agricultural practices, with the intent to reduce microbial risk on the farm. And then in the end, promote safe, healthy produce. And then also, ultimately, I always try to sort of help growers maintain economic viability. A little bit later, I'll talk about some of the challenges that growers have in implementing these good agricultural practices, especially through soil amendments. But at the end, growers are not in business to do produce safety. Hopefully they are doing these practices through their standard production, but in order to be a viable, healthy farm, they have to be sustainable, right? So a lot of the practices I'm going to talk about today are hopefully what I like to call those double smiley faces, right? So they might promote safe produce, but they're also going to be helping those farms in their businesses and their yield. So a little bit about the produce safety rule, just to sort of set the stage. This is a federal regulation, the Food Safety Modernization Act. All total, there are 9 different rules, and the idea is that they span farm to fork. So if you think about the farm, the produce safety rule, where fruits, vegetables, produce are being grown, harvested, held. And then it also includes production, or manufacturing, animal feed, human feed. There are 9 rules in total, including import rules that sort of address importing of produce and food into the United States. The idea behind the produce safety rule is to prevent food safety issues. So it essentially gives FDA, the Food and Drug Administration, the capacity to, instead of just cleaning up after outbreaks and addressing outbreaks after they've occurred, it's essentially allowed FDA for farmers, the produce safety rule, to require these practices. So it regulates these risk reduction practices on the farm with the idea of promoting safe produce. The thing I do want to mention here is this is the first federal produce safety standard. So it was published and passed in 2011. We started to see the first compliance dates in 2016. But this is the first federal standard, meaning that a lot of farms are stressed about this. And this is where the extension and outreach come into play. Before FSMA, produce safety was known. Again, I mentioned good agricultural practices. It was largely market driven. So if you are thinking about farms that are trying to sell to Wegmans, I know you all love Wegmans up here. If you are selling to Wegmans or even restaurants, wholesale accounts normally, food safety started to become required in the early 2000s or so. So a lot of those larger farms were familiar with these produce safety practices, but again, it's a big stressor and now it's a requirement for these farms. So just to sort of finish setting the stage, why are we talking about produce safety? I wanted to highlight this publication from 2019. And this is sort of a report of different multi-state fresh produce outbreaks from 2010, 2017. A couple of things I want to note here. First of all, you can see the diversity of crops. Sometimes when I work with growers, they're like, why me? How often do you hear about carrot outbreaks? Used to be, how often do you hear about onion outbreaks? And we do hear about some of those more often, right? So the produce safety rule addresses all what they call covered crops. So these are crops that are normally eaten raw. So you can see there's a diversity here. If you look into this paper, a couple of other things to note are from the outbreaks. Does anybody know what an outbreak is? Can anybody want to give me a definition? Okay, so an outbreak is normally when there's 2 or more people that are sick from the same causal agent. So maybe from eating the same red onion or the same romaine lettuce, to use a couple of recent outbreaks. When we see multi-state outbreaks, it's kind of like what it sounds. So multi-state, there are multiple states. People were sick in multiple states from that same causal agent. The other thing I want to highlight is when we look at epidemiology and outbreaks, there are a lot of outbreaks where we never figure out what caused that outbreak. And I don't remember the exact numbers, but the thing here is that these were outbreaks that were linked specifically back to produce. But there are a lot that they just sort of never figure out because we eat such a diversified diet these days. Okay, and the last thing on this slide is when we say outbreaks, the major outbreaks that caused the major microbes that caused these outbreaks were bacterial, E. coli, O157H7, Salmonella enterica, and different serovars, and Listeria monocytogenes. There were also one hepatitis A virus and one cyclospora outbreak. So a virus and a parasite, respectively, but the majority of these are bacteria. And this is relevant because now that I'm moving into a discussion of soil amendments, most of the examples you're going to hear me say are bacterial pathogens. Okay, so in food safety, or in produce safety, when we look at sources of contamination and cross-contamination to produce, mostly on the farm and packing houses from the produce side, we usually can point back to one of these categories. And these are either original sources of contamination. So I like to think about, where the feces are. That's often what it's kind of down to in produce safety. So you're looking at humans, animals, or sources of cross-contamination. So these could be additional vectors like soil amendments we're going to talk about today. And oftentimes soil amendments are feces of animals or other parts of animals. It could be buildings, equipment, and tools. So we talk a little bit about cleaning and sanitizing, and then water that's used pre-harvest, post-harvest. But today we're really here to talk about soil amendments. So I'm going to switch gears here now that we sort of set up the stage about why is produce safety relevant for farms today. And I want to highlight why are soil amendments used on farms. And I love using soil amendments as the example because I think sometimes when we do produce safety outreach, we get kind of caught up on the food safety or on the food science side of things. Obviously, we want to keep people healthy. But again, there's also the production side to consider. And on a lot of farms, especially organic growers, they're somewhat limited on the inputs that they can use on the farm. So when they're thinking about improving soil health on their operations, they have somewhat limited options, right? So in terms of improving soil health, we're looking at cover cropping, crop rotation, modified tillage practices. This could be no-till, strip-till, and then also applying soil amendments. So I think a lot of you are in the Hort department, so I don't need to get a lot deeper about that, but I just want to highlight that when we're working with growers and saying, here's the lowest risk thing you do, we really have to be important that it actually fits into their operation and is sort of a reasonable recommendation. And I want to note that a lot of growers are going to be using these options in combination. So specifically looking at soil amendments, the FSMA produce safety rule regulation is all about the definition. So I always want to stop and sort of take a moment and sort of set the stage and make sure I'm using the proper definitions. So when I say soil amendment, this is specifically a chemical, biological, or physical material that's added to the soil. And when I say soil amendment, they can pose risks, right? They can potentially introduce human pathogens. And when we talk about the produce safety rule regulation, FDA is specifically focused on what they deem sort of the higher risk of those soil amendments. So that's going to be this lovely acronym, BSAO, or BSAAO, Biological Soil Amendments of Animal Origin. And what that is essentially soil amendments. So they're intentionally added to the soil for some characteristics, and they tend to be from animal origin. So this could be, manure, blood meal, poultry pellets, things like that. And I also want to highlight that selecting a soil amendment for farms tends to be I'm going to say a personal choice, but they're selected for many farm-specific reasons. And I always want to mention this because when we work with regulators or inspectors, sometimes it's like, well, just use a lower risk option. And that's not always due to cost reasons, practicality reasons, nutrient reasons. I live in Maryland and we have the Chesapeake Bay. So I don't know about you all up here in New York, but a lot of our farmers have to do nutrient management permits, and there's a lot of reasons for using very specific soil amendments and when they're applied that fit into their operations. And so a couple of examples that I have here are raw manure, blood meal, and heat-treated poultry pellets. Again, living in Maryland on Delmarva, I see a lot of this my farmers use. So again, talking about some of the benefits of soil amendments, I'm not going to spend a lot of time here, but reasons that growers use it, increased organic matter, that's really one of the primary reasons. Growers will often use other fertilizers to get the nutrients, but this is often all about building up soil, improving soil fertility, the structure of the soil. I used to live in, as Betsy mentioned, I used to live in California, in Southern Maryland, very dry. So a lot of our growers out in the Southwest were really focused on using compost as a way to sort of help with water holding capacity, add in that organic matter so that they could then make their water go a little bit longer. Okay, so switching back to the regulation, the Food Safety Modernization Act Produce Safety Rule, I want to highlight a couple of things in this illustration. So this is an illustration we've learned in extension that some of our slides tend to be quite wordy, and we work with growers who don't always speak English, they don't always speak Spanish or even other languages where our curriculum is translated. And we've learned that using photos and illustrations goes pretty far. So we have a series of extension materials that are essentially illustrations for produce safety that we can add into presentations. And this is one of those. And I love that this sort of helps set the stage on the different categories of biological soil amendments of animal origin, BSAO, that are regulated in the produce safety rule. So the first category is untreated BSAOs, or untreated biological soil amendments of animal origin. These are examples like we can see fish parts, fish heads. Up in Maine, they do a lot of crab parts, seafood. In Delmarva, I mentioned we have a lot of poultry litter. This could be, areas around here with a lot of dairies. This could be cow manure. And then the second category are treated BSAOs, or treated soil amendments like compost. So these have gone through some kind of risk reduction treatment step. And the key here is that untreated soil amendments are higher risk, and then treated soil amendments tend to be slightly lower risk. Okay, so using a couple of examples that I wanted to highlight, starting with raw manure. an example of an untreated soil amendment. I mentioned that all manures can carry human pathogens. Um, Again, one of the things about using raw manure, we were at a workshop a couple of weeks ago, and I'll say we got to play with raw manure, and it was pretty fresh. So um, this was specifically cow manure, but the key here is that raw manure is higher risk. But when you survey growers, this is specifically from a survey of organic growers nationwide, about 58% of growers were using raw manure. 74% did not treat prior to applying to fields, and the majority of these uses were specifically on produce fields. I'm mentioning this because when we work with growers in extension, it's really important to sort of meet them where they are. Ask them, why are you using these things? And I say this because when we work with other collaborators, especially regulators, sometimes these conversations go as, well, they should use the lowest risk one. It's an option for them. It's like, well, it might not fit into their operation for some of these reasons. And growers cited some of the reasons for using animal manure, raw manure, as soil health was a really big one, nutrient management, soil tilth, cost. Raw manure tends to be cheaper because it hasn't gone through all that labor of the treatment step. Some of the other examples that I ran out of room, but waste utilization. So if you see diversified operations, a lot of those sort of try to keep it all on the farm, right? They're trying to recycle that waste and use it in a productive way. So the other thing I want to kind of highlight here is that in extension, when we're working with growers, it's all about communication and making sure we are using the correct terminology. And I love this point because it's really important to when talking with growers often think, this is what I'm doing. I'm communicating that well. And in extension, we like to think that we're also okay communicators. But it's important to use the same words. And the example I have here is this topic of aged manure. There have been countless times in grower training courses or train the trainer courses or workshops where I'm working with growers and they're like, yeah, we use compost. And then we start getting into, you'll see in a little bit, we start getting into how do you treat your compost? Tell me your steps. What temperatures are you hitting? And they're like, well, we let it sit there, but it's really old. It's like 10 years old. We have our horse bedding, which sometimes practically composts itself. You're sitting it out there, but there's no manage. We like to call that minimally managed compost. Sometimes it's also called aged manure. So the point I'm getting to is when in doubt, especially for farm-specific scenarios, especially when we're educating on a regulation, it's really important to make sure we're all using the same terms. The other thing I want to mention is part of the produce safety rule regulation involves, part of the compliance part involves inspections, right? So oftentimes somebody from the state comes up, so it could be New York Department of Ag and Markets, it could be other state departments of agriculture. They come up and they do an inspection and they will go through their checklist and they'll ask, do you have biological soil amendments of animal origin? And they'll sort of take you through that list. It's really important that growers, when they hear those terms, they're like, oh, I know what you mean. And using this aged manure example, research shows that the process of aging does actually reduce E. coli 0157H7 Listeria monocytogenes. However, it's not consistent. And when we work with soil amendments, there's this topic of sort of, they call them tops and toes, when you're describing the structure of a pile of manure. So oftentimes in the center, that's where we get all the microbial action, right? It heats up, there's more of everything. So it's a little bit insulated, it heats up. So likely we're seeing sort of microbial inactivity here where we're seeing die-off. However, here you have less, it stays cooler, it's not gonna get as hot, it's not gonna be as impactful. And that's really where the importance of having an active treatment process comes into play. So one of the other questions we often get when working with growers who are using raw manure is, how long does it have to sit out there before I can harvest that crop? What are the requirements there? And I always like to point out some of the science when it comes to pathogen die-off is we know this is sort of a traditional die-off curve. What we have here on the x-axis is number of days from application to out. This goes out to 240 days. And then here on the y-axis, we have log levels of E. coli 0157H7. So it kind of makes sense. Here we have a spiked, so this, I will say in this particular study, it is spiked. So you can see it's pretty high. And we have it's applied, and then over time, it tends to die off. There's some spikes here and there. A lot of times those are going to be correlated with rainfall. You add more rain, the microbes get excited, and then they might regrow. But this is a pretty traditional die-off curve. What I want to point out is there are a lot of factors that impact this die-off. Everything from environmental organisms. We know that human pathogens are really happy in our guts. E. coli 0157, H7, Listeria, they do really well in our guts. Once you add them to the environment, they tend to be outcompeted relatively quickly, depending on if 120 days is your definition of quick. But they do tend to be outcompeted by those environmental organisms. Research shows that the more diverse your soil, the quicker things tend to die off. They also have a limited availability of nutrients. They are desiccated, so they dry out. They cannot compete. And they're also inactivated or killed off by UV light. So there are a bunch of different factors. I want to highlight some other factors. Initial soil moisture. So again, a lot of these things impact die-off of those pathogens. The importance for farmers is what they want to do is they just essentially want a number so that they can plan out their crop rotations, right? And they can plan out their practices. So say in the beginning of November, they're going to apply manure, and then they are going to wait X number of days and harvest that crop. If it's a spring crop, right? It's all about the planning. But the behind the scenes is it can be really complex. And I always love this list of characteristics because some of these are things that growers are just not going to be able to control. For example, soil moisture is great, except plants, when we're growing produce crops, they need moisture, right? So you're probably going to be irrigating. So you want some of that soil moisture. Same with seasonality, temperature. So these are great from the research perspective. I find them fascinating and interesting, the complexity, but not always practical for a farmer to say, oh, I can change this. There's a good chance that growers who are applying their soil amendments are applying a specific application rate to get to that level of fertility or nutrients that they need, not necessarily because they're thinking about produce safety as the primary factor. Okay, so with all that to say, growers often say, just give me a number, like what do I need to do? Right now, the regulation does not have an established application interval. They're still doing research. Because that research is relatively complex, and depending, like you all know, depending on the study you read, sometimes those conclusions are a little bit different. It can be very region specific. But the recommendation that we give to growers is that they can follow the National Organic Program 90-120-day rule. So what that means is, if anybody's not familiar, that is allowing 90 days between applying and incorporating that soil amendment and harvesting that crop if it touches the ground. So if it's something like cantaloupes, carrots, leafy greens, and then 120 days, you get a little bit longer if that crop is not touching the ground. So maybe like trellis tomatoes, eggplant, sweet corn, things like that. So the thing I find interesting is that if you actually read the preamble to the National Organic Program, it's not considered a food safety regulation. They actually say that. Used to be on the website, they took that part down, but it's in the preamble. And however, it is sort of used as until we know better, until there's more research to help us come up with a number, that's that interval that we can use. And I found interestingly, in this the survey of organic growers, over 91% followed the 90-120-day rule, which makes sense because these growers, the majority of them were certified organic. In order to be certified organic, they have to follow the NOP, right? So that part kind of makes sense. But in discussions and reading other data in facilitating these discussions with growers, the 90-120-day rule is pretty well respected. Okay, so, oh yeah.
Question on that rule. You said 90 days if the produce touches the ground, 120 days not touches the ground, or the other way around?
Oh, I'm sorry. Thank you. Thank you. Yes. Yes, thank you. Thank you. Great catch. So, yeah. Yeah, no.
BSAAO stands for what?
Biological soil amendments of animal origin.
It's not biosolids.
Correct. Yeah, great question. Let me answer this because I was in a zone and I'm sorry that I completely mixed that up. So yes, 120 days. And the idea is that you want to lengthen. So if the crops are touching the ground, laying on the ground, you want to lengthen that die-out curve, give more chance for inactivation. Thank you. I did not even notice I made that mistake. So thanks. Okay, great question. Biosolids. I only had 40 minutes, so I did not mention a slide about biosolids or human waste in here. So the federal regulation, the FSMA produce safety rule, specifically prohibits the use of human waste on produce fields unless, and they use the term, sewage sludge biosolid, which is actually sort of a made up category. So let's talk about this. Biosolids specifically tend to be very well tested, treated, right? And they're regulated through the EPA, through the Environmental Protection Agency. They are tested, treated, monitored for heavy metals, pathogen content, et cetera. Growers can use those biosolids, Class A biosolids especially, there's a couple different classes. They can be used in the produce safety rule. EPA also establishes they call them treatments. These could be alkalizing human waste. They can be applying a application interval. So the produce safety rule, I mentioned this later, is we consider it like a baseline food safety requirements. When I work with growers, I always tell them, know your buyers before you start using things like biosolids. I should have mentioned biosolids are treated human waste. I forget if I said that. Know your buyers because National Organic Program, for example, prohibits the use of biosolids on the farm. A lot of states have more specific or more strict regulations. And a lot of buyers, if they hear that produce growers are using some type of human waste, including biosolids, they don't like that. So again, it's sort of always know your thing. But specifically the definition of BSAO, biological soil amendment of animal origin, specifically says this does not include human waste because they consider it to be a different risk profile than animal manure. Good question. Okay, so I talked about raw manure. Here we go. The other example I want to give is compost. This is an example of a treated soil amendment, so considered to be lower risk. The idea here is that it has gone through a scientifically validated treatment, and specifically the rule outlines 2 different composting methods. Both of these, so one is windrow composting, one is aerated static composting. And in this example, they essentially build up their compost piles and it's not passive, so it's still an aerobic process. So it's using aerobic microorganisms to break down the organic matter and break down that raw manure. So the key here is they're either pumping in air, so it can sort of push out, or they're sucking out air to sort of force oxygen in. And that's how they're building their piles, and you still get a very effective composting process. The other thing I want to mention is other validated processes are allowed. So these are the 2 that if growers are adhering to either these metrics for windrow composting or turned composting, or these metrics, so we have time, temperature, so X number of days, this all has to get to a certain temperature, 131 degrees Fahrenheit or 55 degrees Celsius for a certain number of time. Once that has been sort of accomplished, then it's considered treated in the regulation. Growers do not have to do additional treatment, or I'm sorry, additional testing to prove that. It's all about monitoring the process and keeping those records. What I want to show you, here we go. So I wanted to show you some results from this survey of organic growers. Not surprisingly, a lot of organic growers use compost. This was specifically on their produce fields. And I found it interesting that the majority of compost was purchased commercially, followed by on-site production, about 50%, and local non-commercial. And probably not surprisingly, the main treatments that growers were using were windrow and aerated static. I should mention that these two are also outlined by the National Organic Program. So a lot of organic growers, very easy. They're already doing those processes or taking those records. What I wanted to point out is that these other two, other or not composted on site, 8%, this could be a different type of composting treatment. We often get questions, especially internationally, about bokashi. So there are anaerobic processes, I would say much less research done on those. Static enclosed composting, there is a lot of research to support this, but the key here is for growers that are using one of these other composting, they have to sort of prove that through keeping research on hand. So something to prove to the inspectors that this is still a validated process. So it's a little bit more onus or a little bit more responsibility for the growers to demonstrate that. Okay, so what I want to mention is we spend a lot of time working with farmers, helping them sort of fit these produce safety practices into their operations. And I have a couple of here of what I like to call unique soil amendments. And depending on the region, there are always questions from growers that are like, I'm using this, never heard of it. Korean natural farming is actually, I think, is becoming a lot more popular. We also get this internationally. So one example here is rotational grazing. This is also called integrated crop livestock systems, right? So very popular on diversified farms. We have compost tea, vermicompost. So what I want to show is that there's not always research data to demonstrate or to support every type of soil amendment and showing what that risk profile is. So a lot of times when we work with growers, it's all about asking questions. And then at the end of the day, some of these are not validated to be considered a treatment. So growers are going to be using them as an untreated soil amendment. And then, so again, it's all about considering what the growers are and sort of really having that conversation with them. I did have an example here of working, I'm spending a lot of time about working with produce growers. This is an example of sort of working with adjacent industries in learning about what the needs are when we have these trainings. So these are some quotes that came from this Ramos paper surveying, and this was more of a facilitated discussion with growers. We at Produce Safety Alliance hosted 3 different soil summits to have very similar discussions with produce growers and then compost industry and others in the industry. And I kind of laughed at this because if you remember from the survey data I showed you, I think it was like 75% of growers were purchasing commercial compost. And then a couple of these quotes I found interesting. Growers did not have a trusting relationship with external commercial compost providers. Records given to the farmers did not reflect. So for growers that are complying with the produce safety rule, they have to pass along information. If they're purchasing that compost, they have to pass along information validating essentially that that compost has been treated. So what a lot of sellers do is that they have a certificate of conformance, right? It might be accompanied with testing data for nutrients and whatnot. But what we were finding is a lot of these companies are, I'm going to say like mom and pop companies. They're producing compost. They're around the corner. Sometimes it's good quality, it's good value, but they did not have the appropriate records. So we sort of helped develop it's like a front and back fact sheet and a template certificate of conformance to help for growers to sort of help educate their suppliers and say, here's why I'm asking for this information. Here's a template. Can you help me out? And And the other thing that we've also run into personally when we were prepping for a workshop is sometimes you purchase compost and it's still hot. It's not ready. It's not mature. It's not cured. So there's a good chance that it might not be ready for use on produce farms. Okay, so in the last couple of minutes, I just wanted to highlight to you some additional motivation. So I spent a lot of time specifically speaking about soil amendments, but in the larger context of working with growers and understanding why they are adopting these produce safety practices. These are some results from a recent survey we did with growers. Most of the growers who filled out the survey had attended a PSA grower training course. Not all of them. And we asked them, please rank the top 3 reasons that you are personally implementing these produce safety practices. So here we have the top 3 are meet that federal regulation, personal commitment, and I always find this one fascinating because yes, growers are being regulated, they're being told to do this, but they're also finding a personal commitment to producing healthy produce, right? Supporting their community. And then the last one is maintaining market access, so trying to sell to those wholesale accounts. And together, so the person we worked with is an engineer and he loves these line charts. But together, if you add up these categories, you get to about, I think it's 70%. So those 3 categories accounted for about 70% of the responses. The other thing I want to highlight is the barriers to implementing produce practices. So number 1 is always record keeping. No matter who is facilitating that discussion, there are quite a few publications on this. Record keeping, I always see, is usually up toward the top because it can be onerous. And a lot of farmers, that's an assumption. Not all farmers are great record keepers. And then lastly, I do want to point out, even soil amendments was toward the bottom, right under post-harvest water, which is interesting to me because this is quite complicated, I would say, to comply with. But when you look at soil amendments, time is really that number 1. Time and money are the number 1 factor in terms of barriers to implementing these produce safety practices around soil amendments. Okay, so the last thing I want to mention to wrap this up is when we continue to work with growers and support them through extension and outreach, again, through publications, we've been seeing this, through just discussions with the industry, they often need more information. So some of those examples I walked through today, what are the specific treatments that are required? What are other considerations when I'm using raw manure on the farm? So more information. And then also our training is considered a one and done training, right? So that regulatory requirement is they take this extension training and then they're done forever. But that's not what we see in real life, right? We spend a lot of our times hosting workshops to help growers understand these things and actually get to play with some of these test kits or these activities, doing farm visits, doing this technical assistance, and again, helping them incorporate these bigger ideas like into their operations. Okay, so with that, I did want to highlight our website. A lot of the resources or things that I mentioned can be found on the Produce Safety Alliance website. We have it in English and Spanish, and we are also on social media. And that's where we host, or we sort of promote a lot of our events and resources and whatnot through those accounts. And I think I left some time for questions. You have another correction for me? Because I still can't believe I said that.
I'm wondering if there is, like, when I hear about food outbreaks, I mean, after like meat, deli meat, but for produce, it always seems like it's some like big operation, it's a nationally distributed product. But when you work with these growers and you profile them, like, what's the profile of the most common like food outbreaks we have? Are small scale, like CSA, direct market farmers markets? Do they come up, or are they kind of not having as many issues? Or
great question. Okay. I think there's a lot to be said for the sheer volume. So when Betsy gave the introduction, I think she noted one of the things I learned when I started working in California was the first family farm I worked with had 10,000 acres. I was like, whoa, this is a different scale. So I think there's something to be said for the sheer volume of open air agricultural production, that oftentimes when we hear about outbreaks, I'm going to say outbreaks, and then we also hear about recalls a lot in media, like, oh, so and so was recalled. Make sure you don't eat it. Take it back to the grocery store. We're finding, or what I hear in the industry, is a lot of these companies are being more protective. That if they're doing swabbing, so they might be in their packing house or even in the fields. A lot of these big places are taking field samples. If they get a pathogen positive, they will recall it. So you hear about it a little bit more, or a lot more. We do hear of outbreaks from smaller operations. There's a couple that stick in my mind. A strawberry outbreak from like a number of years ago, from I think deer walking through deer intrusion into a strawberry field. They're not all. The other thing is, you might hear about these outbreaks, but the way, I'm trying to think of how to say this. You might hear about these outbreaks and they might be from smaller family farms, but they're selling to the big distributors. So that's, you hear, I don't want to give names, but you hear about so-and-so. You're like, oh, I know this company. But a lot of times those are actually being produced by these smaller farms that are then selling. So it's not always big industry. Yeah. Great question. There is research, there's also research, like back in 10 years ago, and when I was still at Maryland, we did a lot of swabbing at different organic versus conventional. And there's been a lot of that like microbial survey type of research. And the ones that I've read and participated in, there's usually not a significant difference. Yeah. Between organic and conventional. People argue that, we talked about soil amendments today, that by using soil amendments, there could be inherently more risk because you are using feces, whether treated or not, on the field. But again, it's complex. So. Yeah.
When you talk about amendments, when the growers are using it as amendments, what do you mean by that? This is the soil health, this is nutrients, this is climate control. Why are they?
So like, why are they using soil amendments? Yep. So I had a couple of slides in the beginning about, no worries. So they're using it mostly for soil amendments, building organic matter, improving soil structure, health, water holding capacity, like all of those. So soil amendments, I guess it depends. Conventional growers will often use some kind of synthetic fertilizer as well. Organic growers tend to be a little bit more limited. So I primarily see soil amendments for soil health reasons, organic reasons, with a side benefit of fertility, of adding nutrients. Yeah. And especially when you start getting into like blood meal, bone meal, fish emulsion, not just your manure and compost, that's where you see a lot of those fertility benefits.
This is almost an impossible question to answer. You can have a sense of what % of outbreaks are actually caught and documented.
Ooh.
What percent of what?
What % of outbreaks are caught and documented?
Ooh.
Is there any sense of that? Because I'm sure there's some happening and they just never get reported. People just suck it up and deal with it. That's it.
Okay.
We know.
I don't know how to answer this, but here's what I'm going to say. And yeah, anybody else, Betsy, if you want to jump in. Oh, thank you. Okay. So I'm going to repeat the hard question that I can't answer. So the question was, what percentage of outbreaks I think are caught and documented? Here's what my response is, my half response. When we do trainings or when we work with people, we often say, okay, in order to be a documented outbreak, you need to, the hypothetical the person has to go usually to the hospital, the doctor's office, poop in a cup, get that submitted, get that whole thing going, and then it'll be officially documented into like PulseNet and all of those record keeping. But normally when I talk to people, a lot of times when I'm teaching, we'll do like a hand raising exercise, like who here's been sick? Who here's had a foodborne illness? Raise your hand. And then sort of we say like, who here has gone to a hospital? Usually maybe one person still has it. And then who here knows that they've had that entered into, because sometimes some offices are like, yeah, you got it, but we're not going to do anything about it. and usually all the hands go down. So I would estimate from that, there is a lot of undocumented outbreaks. This is also, I think, the reason when you look at some of the survey data, like the CDC published data, a lot of those, and I'm trying to remember the exact term because it's been a long time since I've read it, but a lot of those are like estimated. They're estimated numbers. So there's always been this estimated number of like 1 in 4 people will have a foodborne illness. That's, I think, one of the reasons they're estimated. Did that answer? Or Betsy?
Surveillance is amazing. So the cantaloupe outbreak in 2011, you all remember the cantaloupe outbreak? They had 7 people sick who had gone to the hospital and they knew it was linked. If you remember the German outbreak, they ran out of dialysis machines before they knew they had a problem. So US surveillance is great. I don't know the answer to your question, but what I do know is US surveillance is top notch. Well, was top, not gonna comment on that. But was top notch in the sense of being able to link them. PulseNet and all the surveillance is fantastic. But yeah, I always love that. How many of you have had your head in the garbage can and your butt on the toilet? Yeah, it's a great question.
Yeah.
So obviously there's a lot of like ongoing research about different aspects of soil amendments and, you know, vegetable and fruit health in general. From like an extension perspective, at what point do you feel when there's, you know, some new like science coming out about one specific aspect, at what point do you feel comfortable enough and like confident enough to go to the farmer and say, we're feeling really good about this, we think you should try it?
Ooh, that's a great question. Okay. I don't think I've ever had that question before. Yeah. Okay. Okay. So the question was, at what point? So there's always research coming out. We've sort of identified that it's complex and there's a lot of research. At what point are we confident in the research to take that and sort of share it with people who are asking questions at workshops? Okay, that's a great question. And I'm going to say it depends. But here's why I say that. There are inevitably people, a lot of, depending on where you are and how excited about soil amendments people get, people are using things like compost tea. Love it. They're like fanatical. Compost tea, vermicomposting. I mentioned Korean natural farming earlier. There is not a lot of like peer-reviewed science about some of those things. So some of those, it's like, I found an article. Here you go. Here's the part that might be relevant. I read the materials and methods and it looks like it's okay. Whereas things like, you know, microbial die-off, there are a lot of studies still happening about that. So I think that partially impacts. I like to have that discussion of like, here's what I'm reading in this publication. Here are concerns I might have, or I'm not even gonna pass it along, but like, here's how, and I would also say in terms of interpreting science, here are the boundaries behind, like, here's what you can do with this. Keep in mind, like, for example, a lot of these studies are initially done in the lab. So that is gonna be way different than an open air environment, even like hydroponic versus open air. So don't get too excited about what this paper says, and you can just say, this totally applies to me. So like, make sure you think about that. So I think usually when we hand off those resources, there's sort of that discussion. Betsy, did you have something to add?
I was gonna tell them the proof of concept for inoculation on things like blossoms or that are not real. If they're real in the,
Yeah.
I was gonna have you go through that one.
Yep. So there's the example Betsy, I think, had in her mind, was talking about was coming from Delmarva, Delaware, Maryland, Virginia area. So especially that Eastern Shore. Back in I think it was 2013, we had a pretty big cucumber outbreak, cucumbers and salmonella. And after that outbreak, so FDA comes out, does their investigation. I think we're gonna get kicked out in a minute, but we're good. So they do their investigation and they will often come out with a report saying like, we think it's often not conclusive. But we think this might be what happened. And in that report, it was mentioned, we think that the salmonella from poultry litter, right? There's a lot of poultry houses, somehow got into the blossom of a cucumber, right? So then it internalized that way. And then it sort of, the cucumber develops and then that salmonella is internalized and growing. That was a proof. So that was sort of an idea. So there was a lot of research around that time about how can we force pathogens, and I say it that way, how can we force pathogens as a proof of concept into the produce? We saw root uptake studies. We saw that through blossoms. The issue is a lot of those were done in growth chambers with very, very high inoculum levels. Again, proof of concept, like, can we make this happen? And then you get out into the field and it turns out, again, because of all those other factors, it doesn't necessarily happen. Yeah. Is that what you're? Yeah.
I noticed in the 90-120 rule that you had talked about, you gave only annual crop. Is it the same for perennials, orchards, vineyards,
Yep.
things like that?
Great question. So those are usually, we call that like side dressing, or it'll be applied around. So yeah, it would be the same. And a lot of times those are up off the ground, so it would be 90 days, not 120. But yeah, it would be. I'm still super embarrassed. But yeah, so it would be the same with those.
You had mentioned that specific applications are going to be dependent on the farm, their situation. Given the higher risk of untreated versus treated, what would be an example of why a farmer might choose the untreated versus treated?
Great question. So, sorry, I keep forgetting about you guys on Zoom. The question was given the higher risk, like why would a grower choose to use an untreated soil amendment versus treated? So great question. Cost is a big one. So compost tends to be a lot more expensive. I did have a slide highlighting some of the additional benefits of compost. Like we're focusing on produce safety, but for nutrient reasons, like nutrient runoff, compost can be better. It's more stable. It's easier to work with, apply, etc. But cost is a big one, right? It's depending on your area. If your dairy down around the corner has a lot to get rid of, it can be free or very cheap. That's a big one. And then the labor and time for actually doing that treatment step. Yeah. And then also record keeping tends to be easier. Again, from the produce safety side, not necessarily from the nutrient management side, tends to be a little bit cheaper or easier for record keeping. Do we have time for one more? Yeah.
One more.
One more? Okay.
I'm more interested in biosolids, what we call stepwise switch sludge, total different. And I mentioned that I want to know who is responsible, I don't know, who is the regulatory organization for the categorize and test them for a specific type of the switch sludge is treated, and how farm you're trusted to use that. So,
sorry, what was the last part?
farm interested to use those type of biosolids.
Are they interested in using them?
Yeah, based on your experience.
Great question. Okay, so the question was, okay, wait, and you guys, I just realized I'm wearing this, so I think they might be able to hear. Okay. So the question was, who regulates sewage sludge biosolids? And then are growers interested in using them? So federally, the EPA regulates biosolids, right? So they establish there's a whole structure, Class A, Class B, there's others. And they have those regulations. So if you look at Milorganite or other biosolids, it has that information often on the back or in the label. Now, growers interested in using them, I would say, from what I've heard, availability cost is a big one. It tends to be relatively cheap. But there's also, for risk reasons, even though they're treated, it is still human waste. So we have seen some studies where if those biosolids or land treated with biosolids or applied with biosolids, if it gets contaminated, those human pathogens will regrow kind of relatively quickly. The other thing, and I know I'm talking about microbial produce safety, but the other thing that we're learning is PFAS, microplastics, and those are a big topic of conversation that I'm not super qualified to talk about, but definitely that we try to bring up as a consideration. Yes.
Would not let that go in Texas.
Yes, that's right. Yeah. Yeah. We did a workshop recently where people were like, talk about PFAS. And I'm like, that we're talking about like the edge of my knowledge. And they're like, we want to talk about PFAS. So yeah. because I mean, these are chemicals that will they can forever alter their soil, right? So, yeah. Okay, I think I'm getting pulled off. Thank you all.
This has been a production of Cornell University, on the web at cornell.edu.